Hi everyone, my name is Lydia, and this is what I wish they taught me about econometrics and introduction. So far, we've learned that dummy variables are extremely useful in regressions due to the kind of information that they encapsulate for us. But there is one rule we must follow when including either dummy variables or categorical variables in general. And if we break this rule, the regression will not be estimated, or if you're trying to use a software, the software itself is going to have to take action so that the regression then can be handled correctly. The problem that we're going to talk about, and that should be avoided, is the dummy variable trap. Let's start with a simple category example, and let's stick to the example that we've been using so far in this little mini series for the dummy variable, where we've got D1 in this case, where we're going to note 1 for employed and 0 for unemployed. Then we're going to create another dummy variable, D2, which is going to be 1 for unemployed and 0 for employed. Okay. Now, notice something very important in here. If you had this in an Excel spreadsheet and you had D1 in here and D2 in here, this is person 1, 2, 3, and 4. If person 1 is in fact employed, meaning that D1 is going to be 1, that means that for D2, he's going to be a 0 for the unemployed category, right? Because he's not unemployed. Then person 2, if he is unemployed, given the information of D1, then obviously he's going to be 1 for the second dummy, where 1 is associated with unemployed. If we keep doing this for all of the cases, what we're going to notice is that for every line that we see in here, 1 plus 0, that's 1. 0 plus 1, that's 1. 1 plus 0, 1, 1. So it doesn't matter if you have a 1 for D1 or for D2. At the end of the day, if you take the sum of D1 plus D2, the total is always going to be equal to 1. So this column here, D1 plus D2, is going to be full of 1s. So that's going to be always 1. Okay? Now, let's put both dummies in the regression to see how exactly things are going to go wrong, because we already know now that this is going to be all about the dummy variable trap. If we have a model, y equals to beta 0 plus beta 1 d1 plus beta 2 d2 plus an error term, u. And remember, we're still under the assumptions that d1 plus d2 is equal to 1. The intercept is going to now be equal to 1 for every single observation, okay? So that means that one variable, since you have like this relationship d1 plus d2 equal to 1, one variable is a perfect linear combination of others, of other variables, okay? And we know, especially since we've seen the assumptions for the multiple regression, where we change the variance of X assumption into the no perfect collinearity existence, having one variable that is a perfect linear combination of the others means that we have perfect collinearity, and something is wrong. Something will fail with other regression. If you remember from also the matrix notation, what it means is that now the matrix computation x prime x in here, this is no longer invertible. So technically, Stata, which is using matrices in the background to do all the computation necessary to give you a value for B0, B1, and B2, it's not going to be able to do this computation and to find the actual beta hat as x prime x transpose minus x prime y, okay? So this now can no longer be compounded. Stata or any software that you use will drop the variable, one of the variables in any case, automatically. So what is the solution? The rule is very simple. If a categorical variable has k categories, include only k minus 1 dummy variables. Okay, so one category, and that is usually the one dropped, okay, becomes the benchmark group or the reference group. Okay, so I know that here I'm using categorical, but keep in mind a dummy is just a categorical variable with just two options available. So in this case in here, we clearly saw that D1 plus D2 was equal to 1. You had a perfectly linear combination between the two, so it suffices for you to either drop B2 or to drop B1 out of here. Okay, so whichever you want to drop, it's completely fine, but then keep that in mind because that becomes your benchmark, your reference group. The same thing can be applied. So if instead, so another example, if instead now I don't just have two options, let's say that I have three options. I have unemployed, I have part-time, and I have full-time. These are my three categories. And if I come up with a dummy variable for each of these options, so let's say D1, D2, D3, then it's obvious that D1 plus D2 plus D3 have a relationship where the sum is equal to 1. What does that mean? You have to take out, let's say we take out part-time categories. So in your regression, you're just going to have beta 0 plus beta 1 D1 plus beta 2 D3 plus an error term. And the D2, so this part-time category that you have left out, will become your base group. Okay, so it means that this B1 in here is going to be the difference from the part-time, while the B2 is also the difference from part-time. Okay? So the key takeaway, with k categories, include k minus 1 dummy variables to avoid perfect multicollinearity. I hope this was helpful, and I'll see you in the next video.